In this course, we've already looked at some basic data frame manipulations. In this chapter, we want to do something a little bit more advanced, and in this case, we want to take either two or more data frames and we want to squish them together, or we want to take one data frame and we want to rearrange it so that we either stretch it out or we squish it to be much wider. But these are pretty advanced data frame manipulations, but they're really, really important. So they get their own chapter. I just want to make an aside talking about data frames versus tibbles. Data frames are the base R way of storing data, while tibbles are the tidyverse way of storing data. Really, a tibble isn't that much different than a data frame, but it, as Hadley has been known to say, it complains more and it does less. The rationale is that it doesn't do things behind the scenes. If you want something to happen, you have to be explicit about it, which seems like it's something annoying, but when you're programming, being predictable and consistent in your behavior is much, much, much better. And so as a result, typically I'll deal with tibbles more often than I want to deal with data frames. The other thing that's nice about tibble compared to base data frames is that tibbles allow you more flexibility in your column names compared to base R. In base R data frames, you can't have numbers as column names, and your column names can't have spaces or other characters. Tibbles don't have that requirement. In this case, I've got a data example where I've got a column name that is a number, and that's fine, and another column name that has a space in it, and this is completely fine. Now, the only caveat is that when you deal with that, you have to put these things in quotes, and typically I see it in back quotes, but single and double quotes seem to work just fine as well. So tibbles have a little bit more flexibility in the column names. The base R version of squishing two data frames together is usually done by two functions called cbind and rbind. The bind part is the squishing, and the C and the R stand for whether or not we're binding together by columns or by rows. I'm going to do a little example, first doing a column bind. Now I'm going to define this is going to be a tibble, and I've got three rows here, and I've got an ID column and a first name column. And what I'd like to do is I'd like to make another column that is their last name. And I'm going to do this by creating another tibble where this is just a data frame that has just a column for last name. And what I want to do is I want to squish those together. But the requirement is that both of these data frames have the same number of rows. Because if I try to squish together something that has more rows than the other one, then what do? Ideally, it would fill it in with NAs, but it doesn't always do that. So cbind requires that they have the same number of rows. So what I'm going to do is I'm going to take my first data frame, my second data frame, and I squish them together, and this is my resulting output. Now, squishing together by rows is pretty much the exact same thing, except now we're going to require that each of my data frames that I want to squish together has the same number of columns. So I'm going to make another data frame. This time it'll have three columns, an ID, a first name, and a last name, and I'm going to squish it together with what I've already got. And now this is going to add this as a new row down at the bottom. So this is the first data set, second data set, and you just stack them together. Rbind is actually pretty smart in that even if you've got the same number of columns, but the columns are out of order, but they're named correctly, Rbind can still figure out what to do correctly. So notice in this case, I've got a first name and then my ID column. And so the ID and the first name are actually swapped, but Rbind still figures out what to do because they have the same column names, but just they're switched around. Now, unfortunately, if you add a brand new column, so in this case, I'm going to add a date of birth column and try to squish it together. Now, this is not going to work because people has just 3 columns, where this df5 has 4 columns, and rbind freaks out. Now, dplyr has 2 equivalent functions to rbind and cbind, where they're just called bind rows and bind columns. And this works a little bit more intelligently where it says, oh, you want to squish these together? Well, you've got equivalent columns in both of them, but one of them has this extra column called date of birth. So what I'll do is I'll squish them together like you asked, but I'll insert missing values for the data set that is missing that particular column. And that seems to be a much smarter and robust thing to do rather than just throwing an error. Suppose I've got some data, in this case what looks like a grade book to me, and I've got 3 students here and we've got 4 different homework assignments here. And so here we see Allison has a grade of an 8, then a 5, then an 8, then a 4, etc. So this looks like a common piece of data that you might see. But the thing about it is that there's no requirement that I store my data like this. Here I have 1 row per student, but that doesn't necessarily always lead to the easiest way of interacting with the data. I've got another alternative way of having the data, and here I've got 3 homework scores, 1 for Allison, 1 for Brandon, 1 for Charles. And then for homework 2, I've got another row for Allison, another row for Brandon, another row for Charles. So I've got all the same data. I still have 12 observations of homework scores and associated students, but in this case, I've sort of stored it in a wide format where I've got 5 different columns. And over here, I've stored it in sort of a long format where I've only got 3 columns, but I've got 12 rows. And so the idea here is in this top case, this long format, I've got 1 row per homework assignment. And down here in this wide format, I've got 1 row per student. Neither of these ways of storing data are necessarily wrong, but I need to be able to move in between either of these because certain types of analyses or graphing might be more convenient to do in one format or the other format. And so I need to move back and forth. So we're going to start out our example with it in wide format. And now what I want to do in order to get it into this long format is somehow I need to turn these 4 homework columns into just 2 columns. And I want 1 column that sort of encodes this information that is the column names, and I want another column that encodes this information that is the scores. All right, so the function that we're going to use to do that is called gather. And what this is going to do, this is going to gather multiple columns up into 2 columns that have the column name and the value. So that's what we're going to do. We're going to take our gradebook scores and I'm going to gather, and first off I'm going to tell it which columns do I want to gather up. So this is going to be all the columns that I want to get collapsed into 2 columns. And then the last thing that I need to do is give it the names of the new resulting columns that I want them to be named. So this could be anything. This could be Bob, this could be Fred, but homework should be pretty memorable. Now notice that this thing is called a key, and up here what I want encoded in that key column is the column names. So notice they kind of have the same sound, key, column. Okay, it's K versus C, but yeah, whatever. So I always remember the key is the column names that I want to gather up, and then the value is whatever was in those data cells to begin with, and I want to call those scores. And so I end up with this data set that names just stayed along, but notice it got doubled, or it got copied wherever it was appropriate. And now the key column is what homework column it originally came from, and then score is whatever was actually in that data cell. Now to go backwards, I just need to recognize that this homework is the categorical variable that is going to turn into columns, and whatever this column is should be the cell values. And so now we just go right back the same way, and we're going to take my data set and I'm going to spread out these two columns into multiple columns. And we end up right back here. Now, the same sort of thing happens in Microsoft Excel, except it's called a data pivot. So this isn't a new tidyverse idea. This is very common, but it's done particularly elegantly with the gather and spread commands. All you need to know is what columns and what should the key and the value columns be. Once we have data that is sufficiently complex, it becomes very important to be able to store that data in multiple data files or data tables because the nature of the data is such that that's the most efficient way to store it. As a convenient example, let's consider what a university has to store in terms of the instructors and the courses and the students that take their courses. First off, we've got people, and somehow we need to keep track of information about those people. So we need some sort of unique identifier, not just first name and last name. But there's a whole bunch of stuff about the individual people that we need to keep track of. Separately, we need to keep track of the courses that the university offers. And so every course that we offer has its own sort of unique set of information, like the prerequisite courses that need to be taken, what degree programs it's affected in, and basically a bunch of stuff like that. Now, each of my courses has a section. So if you take Calc 1, there's like 12 different sections that you could take, and each of those sections has its own instructor. And so we need to keep the overall course information, like the prerequisites, separate from the section information that would be something like Section 2, Fall 2020, and compare that to Section 4 in fall of 2020. So keeping those sections different, that's very, very different than the courses. And then finally, there's other things like departments, keeping track of what instructor works in what department. All of those things need to be stored somehow, but I also need to be able to put those together at various points in time. So I might want to be able to say, hey, give me all of the email addresses for the people that are employed by the mathematics and statistics department. Or I need to be able to find what course instructors or what instructors have taught sections of Bio 101 or something like that. So I need to be able to store this information in separate data tables, but I need to be able to join them together. And critically, I need to be able to do the joining with a one-to-many relationship. That is to say, there's only one row in this, maybe I've got a data set for people for a particular student. So John Smith has one set of information in some sort of data frame for people. But when I want to join it with the sections data, well, John Smith has been in a bunch of different classes. And so when I do that squishing together, I need to have all of the information about the sections combined with the information about John Smith. So that's what we're going to do next, is we're going to talk about how do I make that joining when there's a one-to-many relationship. As a concrete example, we've got a data set of blood donations, and we've got some information about our blood donors, and I've got a table here with 3 people, and I've got this donor ID column. Now, this donor ID column is going to be the way that we keep track of individuals regardless of their first name, last name, anything else. This donor ID ID needs to be a unique identifier for each person that we're going to deal with. And then we've got a bunch of other information about that person, their name, their blood type, birthday, where they live, all that sort of stuff. So this is going to keep track of our donors. Next, we're going to have our blood donations. Now, again, we need a nice unique identifier to keep track of every unique blood donation. Now, we could have 2 blood donations coming from the same individual. So here we see donor 1 has two donations, B1 and B2, and then a third one that is B4. So there's a one-to-many relationship between a donor and a blood donation. And this table keeps track of information about that particular donation. So what date it happened, and then maybe some information about the blood that was taken at that point in time. Now, what we want to be able to do is we want to be able to join my donor table with my blood donations table. And clearly, the way we're going to do this is this column right here, this donor ID. This column exists in both tables. And so when I squish them together, what we're going to do is we're going to force this donor ID column to match up. And so what we're going to do is we're going to end up with 3 copies of this donor 1 row, one for each place where this donor ID in the blood donations shows up. So the question becomes, how do I do that squishing? So this is going to be something called a table join, which is a very, very, very common thing to do, and this has been around for a long, long, long time. But there's 4 different flavors of these joins, so let's talk about those next. When joining together 2 tables, there's actually 4 types of joins. We've got a inner join, left join, right join, and a full join. And these sort of correspond to some interesting behaviors. So to understand this, let's start with a little practical example where we have this first table. I've got an ID column, and this is what we're going to use to join the 2 tables, this is ID column. Got an extra column just to show that these are my very first, this is a column in this first table. I've got my second table, which also has my ID column, and a column Y, which is not in the first data set. So notice in this first data set, I've got IDs A, B, C, and in the second one, B, C, D. So this one is missing an A, B is missing an A, and this first one is missing the D. So we've got IDs that exist in one table but not the other. So an inner join says only include the ID rows where you have them in both tables. So when I do an inner join, I'm only going to include the rows for ID B and C because they exist in both tables. A left join says include all the rows in my first data set and augment it with information from my second data set if it exists. So my first data set had IDs A, B, and C, and here's the X column that was there previously. Now this Y came from my second data set. It came from this guy. Now I didn't have any information for ID A, right? This wasn't in my second data set. And so what we've done is we've inserted a missing value for anything that doesn't have anything in this Y column. A right join is just the opposite, where we're going to include every row in my second argument and augment it with information from this first data set. And wherever there's not data, we're just going to put in a missing value. And then the final option is that we're going to do a full join, which says include all the IDs from either table, and if we can augment it, great. If not, insert missing values. So here we have a missing value for the Y, for ID A, and then here we have a missing value for the X, for ID D. It is common to show this joining information using Venn diagrams. And what we've got here is we've got a left join showing that the first data set that you throw in, it's going to include all the rows from the first data set, and then any information that is overlapped in the second data set with the first ID columns in the data set in the first one. A right join includes all the rows in the second argument, augmented with data from the first. An inner join includes information only on the rows that exist within both data sets. And then an outer join includes all the rows from both data sets augmented with NAs as appropriate. Often we want to do some sort of row-wise operation where maybe we want to sum over multiple columns, or maybe take the average, or you can imagine wanting to do a bunch of different things sort of by row. As an example, I'm going to switch over here into R, and I've got this grade book right down here where I've got my individuals. I've got my 3 individuals, and I've got homework 1 through 4. And what I'd really like to do is I'd like to calculate, say, my homework average score. So what I want to do is I want to take homework 1 through 4 and I want to average them. So in order to do this, we are going to do the following code. This is sort of how you would do it tidyverse style, but I'm going to show you something a little bit easier to do this. So first off, we're going to take our grade book, and so this is our starting grade book. And what I'm going to do is I'm going to turn this from a wide format to a long format. The reason why I'm going to do that is because my summarize command, which is really the workhorse for my tidyverse stuff, only works on columns. It doesn't work on rows. So what I need to do is I need to turn it to my long format first. And so now we've got it in this long format where I've got Allison, Brandon, Charles, etc. And now what I'm going to do is I'm going to summarize, but I've already grouped it by name. So what I'm going to do is I'm going to calculate the mean score for my individuals. So that's what this next line does, is it calculates the mean score for Allison, Brandon, and Charles. So this is great, but I actually wanted it back on my original data set. And so because I've got this name category that is still there, I can do a left join back on my original data set. So that's what this final command is going to do, is it's going to do a left join. And I want to do a left join because I want all of the rows in my original gradebook, but I want to augment it with this new thing that has this homework average. And so this is going to make sure that this homework average is the last column in my data set. And here we go. So this is the resulting output, is that we have got this homework average. So this is sort of the tidyverse way of doing things, is to take your data that you want to do a row-wise operation. Instead of doing something row-wise, pivot and make it a long data set, then apply my summarize, which is sort of this column squishing, and then join it back to my original data set. Now that's a lot of code to just calculate a mean of a couple of columns. So I'm going to show you a little something. So this apply function is a really useful thing, and recall that the apply function will just apply a function to either rows or columns of a data set or a data frame. And this margin equals 1 says apply it to each row. Margin 2 says apply it to each column. And so apply really doesn't care whether we are doing things row-wise or column-wise. It just says apply this function to each row or to each column. So we're going to use this margin equals 1 to apply some function to a row of data. But the thing about it is that I don't want to calculate the mean of, where did it go? I don't want to calculate a mean where we have this name, right? Because I can't add a character string inside of an algebraic manipulation. So I just want to select these particular these particular columns, homework 1 through 4, apply a function to those, and then squish it back onto my original data set. So that's what we're going to do. So I'm going to take my gradebook, and what we're going to do is we're going to apply a mutate function to create this new column. And what we're going to do is we're going to take my input data set. Remember, that's what the dot means. The dot means whatever got passed into this pipe function is now going to be replaced by this. So we're going to take my gradebook and select homework row, select the columns homework 1 through homework 4, And that is going to be a smaller data set. That's just going to be those homework rows, or homework columns, excuse me, and pipe that into the apply function, where to the rows I apply the function mean, and the output of this whole command right here will get assigned to this homework average. So this is really nice in that this gives me a work mechanism that will generate this new column in just one line, just this one mutate command. So this looks pretty common, and it only gets a little funny because we've got this pipe command nested inside of a mutate command, but it works. So this little cookbook recipe is going to be really handy to be able to do some sort of row-wise manipulation to whatever columns you want, and these can be selected however you like using starts with, ends with, all of the usual select commands and options. And then you just tell it what function do you want to apply to that row, and you're good. And likewise, I've also got this pipe command going here, just showing that you can just keep going on with your usual pipeline procedure so that you could have calculated this and then do some sorting or whatever you want to do. So this is a nice way to do row-wise calculations within a data set.